You know that powerful AI engine that so many developers already depend on? Well, what if you could give it superpowers? Make it do way, way more without even slowing it down. That's the big promise behind a new framework called vLLM-Omni. And trust me, it's a huge leap forward.
Just think about that for a second. Most AI models today, they pretty much live in a world of words. But our world, it's full of sights, sounds, everything. So what if a single AI could read your request, look at a picture you sent, and listen to a voice memo all at the same time? And no, this isn't science fiction anymore. It's exactly the future that vLLM-Omni is building right now.
And that's where vLLM-Omni comes into the picture. It's this open source engine that gives AI what they call omnimodal powers. Basically, the ability to process text, images, video, and audio all at once. But here's the really critical part. It does all this without losing the incredible speed that its predecessor is famous for.
So let's get into it. What exactly is vLLM-Omni and what makes it such a total game changer? To really get what a jump this is, just look at the comparison. Your traditional language models, they're amazing, but they're stuck with text. vLLM-Omni just completely shatters that wall. It can take in images, video, audio, you name it. Its scope isn't just language, it's omnimodal, and it's all running on a supercharged, accelerated engine. And this, right here, is the kicker. Usually when you add more features, things slow down. It's a trade-off. But vLLM-Omni was specifically built to avoid that. It handles this huge new variety of data while keeping that same blazing fast speed of the original vLLM. It's all about getting more power without paying the performance price. All right, so we know what it is, but how can you actually use it? Let's get practical and see how developers can put Omni to work today. This framework is obviously really powerful, but how easy is it to get your hands on? Let's take a look. So right now, there are two ways to think about this. You've got offline inference, which is for processing stuff in batches on your own machine. That works perfectly right now. But then there's online serving, which would let you run a live, persistent server that people could connect to. That part is still in the works. So for now, all the action is happening offline. So what does offline inference actually look like for you? Well, it's surprisingly straightforward. You just run a Python script. It's absolutely perfect for churning through a folder of images or handling other big tasks locally. The script runs, does its thing, gives you the output, and then it's done. No need to mess around with managing a server. Okay, but wait a minute. How does vLLM-Omni manage to handle something as complex as image generation so incredibly fast? Let's pull back the curtain and look at the clever engineering behind its speed. To really appreciate the solution, you first have to understand the problem. Diffusion models, the tech behind all those amazing AI image generators, are unbelievably powerful, but they've got a major Achilles heel. They are notoriously, painfully slow. And here's why. To create just one image, that model has to run through over 50 different steps, and with each tiny step, the entire massive model has to run all over again, even if the change is super small. It's just a really repetitive and inefficient process. So that's the big bottleneck, right? A slow, repetitive, and computationally expensive job. The big question is, how on earth does vLLM-Omni get around it? The answer isn't one single magic trick. It's a whole suite of really clever optimization techniques that all fall under one name: diffusion acceleration. It's a bunch of smart methods all working together to speed the whole thing up. And within that toolkit, there are two real heavy hitters we need to talk about. The first is a smart caching system called Tcache, and the second is a highly specialized diffusion transformer they call Cached-It. Let's start with Tcache. Think of it like being an artist. If you want to change the color of an eye in a portrait, you don't repaint the entire canvas from scratch, right? You just touch up that one little part. Tcache basically does that, but for computation. It checks the changes between steps, and if they're small, it just reuses the results from the last step. No need to do all the work over again. Now, Tcache gives a really nice boost, for sure. But the biggest speed gains, the real secret sauce, comes from an even more advanced method. That specialized transformer called Cached-It. Cached-It is like a three-part master plan for efficiency. First, dbCache acts like a bunch of mini caches, saving results from different parts of the model and only rerunning the bits that are absolutely necessary. Then, Taylor Sears does something amazing. It uses some clever math to predict what the next step will look like, which often means it doesn't even have to compute it at all.
And finally, SCM masking takes it even further. It dynamically decides to just skip entire steps if it figures they won't make a big difference to the final image. It's all about avoiding wasted effort.
So what's the point of all this fancy footwork? Tcache, cache-edit, all of it. It's simple. They all work together to take that slow 50-plus step process and make it fundamentally, dramatically faster.
So where does all of this leave us? Let's zoom out for a second and look at the big picture and what the future of AI inference could look like with tools like this. Okay, so here's the rundown of where we are today. vLLM-Omni is an absolute beast for offline batch processing tasks, all thanks to that diffusion acceleration magic. The next big hurdle, the next item on the to-do list, is ironing out the kinks with online inference to get it ready for live apps.
But the excitement for its future is really high. The team at Marlin AI put it perfectly. They said once those online issues are solved, this framework is going to be as superb as we have VLMs. And that's a really powerful vote of confidence in its potential.
And that kind of brings us to the final thought here. We are building AI that is not just faster, but also way more perceptive. It can understand our world through text, images, and sound. And that leads to a pretty fascinating question. As these tools become more and more powerful, what amazing new worlds, what incredible new possibilities are they going to help us create?